Hello, my name's David Morrison. I'm a research scientist at Applied Computing Research Labs, and today I'd like to demo some of the new features in our software product SimKube. SimKube is a record and replay simulation environment for Kubernetes. It's designed to help you understand, reason about, and predict the behavior of your production Kubernetes clusters without breaking the bank on cloud costs. The way that SimKube works is it takes as input a trace file. The trace file is just a collection of events that you'd like to replay in your simulation environment. Your simulation environment can run either locally on your laptop or in the cloud, but in a much smaller environment. Here's one example of a trace. You can see that the first event in the trace file sets up the initial state of the system that we'd like to simulate. Here we create 27 different microservice deployments in our Kubernetes cluster. This particular trace file is simulating a social network graph, and so you can see that we have deployments in here that allow you to do things like compose posts, browse your social graph, upload media, and so on and so forth. This trace runs for about 20 minutes, and you can see as time passes how the trace file evolves. After about 7 minutes in our simulation, the social graph service increases its replica count to 3. After about 9 minutes in the simulation, we have 3 deployments: URL shorten, compose post, and home timeline service that also all scale up. This one goes to 2, compose post goes to 4, and home timeline also goes to 2. We can run this trace file in our simulation environment using the Scuttle command line tool. Here, I'm running the simulation locally on my laptop in a kind Kubernetes cluster. I've turned off fine-grained metrics collection for the purposes of this demo. You can see that after I started the simulation, a new pod has appeared in my namespace. It is 8 seconds old. This is the simulation driver. The simulation driver is responsible for replaying all of the events in our trace on the cluster. We can take a look at the namespaces in our cluster. Here you can see that a new namespace has been created called virtual-DSB. This is where all of the objects in our trace are going to get created. We can switch over to that namespace now. Let's take a look at what's inside. Here you can see that we have 27 different pods. These correspond to all of the pods that were present in the initial state in the trace file that I showed you earlier. Now, one question you might have is, where are these pods actually running? And the answer to that question is they aren't. We can take a look at the nodes in our Kubernetes cluster, and you can see that we have a control plane node that's running our API server and scheduler, a worker node that's running the simulation driver, and then we have a node that's provided by Quack. Quack is the Kubernetes without kubelet project. The way that it works is by faking out the data plane of your Kubernetes cluster. So this node is not real. It's simply reporting all of the status effects as if it were real. We can take a look and see what that looks like. Here you can see all of the pods that are running on that node. Of course, none of those pods are actually doing anything, because the pods themselves aren't real either. There's no Docker, there's no application code involved. This is how you're able to simulate thousands of nodes easily on your laptop. We can also take a look at this in Grafana. On this dashboard, I'm plotting all of the running pods in the virtual DSB namespace. You can see that, just as shown in our initial setup in the trace file, there are 27 pods. You could further break down these metrics by deployment if you wanted to watch the individual services scaling up and down. Since this simulation takes about 20 minutes to run, we're now going to jump ahead in time so that you can see the full scaling activity of the simulation once it's complete. Welcome back. The simulation is finished now, and you can see the full course of its scaling activity. We started down here at 27 nodes. We scaled all the way up to about 52 nodes, and then we scaled that back down once the simulation was complete. I mentioned before about Quark and the virtual nodes that it creates. We can also take a look at how that behaved over the course of the simulation. So I'm using Carpenter to scale up my virtual nodes. We started off with one virtual node for the first 10 minutes or so of the simulation, and then as the number of pods in the simulation scaled up, I also increased the number of virtual nodes. So here we scale the number of virtual nodes up to 5, before finally peaking at 8 virtual nodes managed by Quark before the simulation finishes. Now, the cool thing about this whole process is that we can replay the same trace file as many times as we want to. We can go in and try a different autoscaler, for example, the Kubernetes cluster autoscaler. We could change some parameters about the EC2 instances that we're scaling on. Or we could change some of the configuration in Kube Scheduler about how it's scheduling pods. We can test all of these out in our simulation environment without needing to spend a ton of money on cloud resources. And because the control plane is all running real Kubernetes code, we have a high degree of confidence that it's going to behave the same way in our production environment as it does in our simulated environment. If you'd like to know more about SimKube or about any of the other work that we're doing, you can visit simkube.dev, where you can find the trace file that I used in this demo, as well as links to official documentation, our source code, our KubeCon talks, and others. Once again, this has been David Morrison with Applied Computing Research Labs. I hope you've enjoyed this demo of SimKube, and if you need any help simulating or analyzing the behavior of your Kubernetes clusters, please reach out. I'd love to do what I can to help you. Thanks for watching.